It's Algebra 1, Lesson 7-4. We're looking at inverses today, inverse functions. The inverses you've been familiar with since Algebra 1 are the inverse operations, like addition cancels out subtraction and vice versa. Multiplication and division are inverses of each other. And then taking the square root of something is the inverse of squaring it and vice versa. Today we'll look further than that. We'll talk about cube roots and things raised to the fifth power and stuff like that. You treat them all the same way. These are talking about the inverses of functions, though, beginning on page 422. First thing is what's an inverse relation? Remember, relations are how when you plug an x value in, what's its y value come out to be. The difference between a relation and a function is that all functions are relations, but not all relations are functions. Remember, the only way that you've looked at it when you're talking about graphs is if you have a graph that looks like this. When it passes what's called the vertical line test, that's something you got to think way back to. The vertical line test that makes it a function. The reason it is because when you map it out, if you have like 1 and 2 and 3 and then 4, 5, and 6, if all of them go to one thing, or if there's only one arrow that leaves each one, it's going to be a function. The definition right here, though, is talking about a relation. It says a relation that maps the output values of an original relation back to their original input values. All it is when it says it maps them back to their original, if you're talking about the mapping like what I just showed you, 1, 2, and 3, if they're going to 4, 5, and 6, you would map that by drawing arrows that go like this. We've all done similar things to that before. Sometimes you draw ovals and stuff like that. When it's talking about an inverse, all you're doing is this. It's not really a trick or anything. You're just reversing everything and going the other way. That's what it means by an inverse. An inverse function, on the other hand, says an inverse function is a relation and its inverse relation whenever both relations are functions. So when both of them are functions, then it's considered an inverse function. Now, again, the other example I showed you a minute ago is if you have a graph that looks like this and it passes the vertical line test, then you know it's a function. When you're talking about the inverse of that, you're doing the exact same picture, but you're doing its inverse. Like if you used this point and this point and this point, for example, just to show how that would be. Let's say that that's 0.11. Then you'd graph the other one at 0.11. Say the next one's 0.22. That one would be at 2.2 and then be at 3.3. It works better when you have opposite numbers. Its inverse would look like that as well. That's what the inverse function would look like because the x and the y values would be switched. But when you're checking the inverse, you're checking using what's called the horizontal line test. You're doing the same thing. You're checking it horizontally, though. So if you see something that says the horizontal line test, don't freak out or anything. That's just checking to see if the inverse is, in fact, a relation or if it's a function. The relation's a function. Okay, example number 1 is finding an equation for the inverse of the relation y equals 3x minus 1. The first thing you want to do is you want to take x and y and swap their positions. That'll be the thing you'll forget to do once you start doing all this because it's real easy to forget. Switch their positions. Notice on line 2, it says x instead of y is equal to 3, y instead of x minus 1. After that, then just solve for y. Just like we did on the bell work, get rid of minus 1 by adding 1 to each side. So x plus 1 is equal to 3y. And then get rid of 3 times something by dividing by 3 on both sides. When you divide by 3, that's like 1 divided by 3 in front of that x. There's a 1 right there, even though it's not shown. That's why it becomes 1/3 x. And then 1 divided by 3 becomes 1 over 3. So y equals 1/3 x plus 1/3. Therefore, the inverse relation is simply that. Switch positions of x, y, and then solve for y. Y equals 1/3 x plus 1/3. It's not any harder than that. Okay, here's another example. Y equals negative 3x plus 6. Take about 30 seconds and find the inverse of that one. All right, everybody, we got y equals negative 3x plus 6. The first thing you want to do is you want to reverse positions with x and y. So you'll have something that says x equals negative 3y plus 6. Once you do that, solve for y. Undo plus 6 by subtracting 6 on both sides. So you have x minus 6 on the left equals negative 3y on the right. Then get rid of negative 3 times y by dividing by negative 3 on both sides. Divide everything on the left by negative 3. Remember, this is 1x. So just like it was on the last example, that's going to be negative 1/3 x. Negative 6 divided by negative 3, and negative divided by negative is going to be a positive 2 equals y. There's your inverse function. And it's not any harder than that. You don't have to switch the x and the y back. You leave it just like it is. Inverse functions. Functions f and g are inverses provided, and you read this as f of g of x. So if you ever see anything inside of multiple sets of parentheses like that, just read it from the outside in. F of g of x is equal to x, and g of x, g of f of x is equal to x. Notice they're both equal to the same thing. You read it as the function g is denoted as f. You read it as the inverse, so read as f inverse. Anytime you see that negative, you don't read it to the -1 power. That's just showing the inverse. And some of y'all looked at your calculators, you've seen those -1s raised to a negative power like that. You use them with SOHCAHTOA sometimes. You use it with trig functions. All that's talking about is the inverse of all of those functions. Example number 2, this is verifying inverse function. It says verify that f of x is equal to 3x minus 1, and the inverse of f of x, notice how I read that, the inverse of f of x equals 1/3 x plus 1/3. Now we just did this one a minute ago in reverse, so we know it's going to work, but this is how you show that it's verified, to see that they're both equal to x. They both have to be equal to the same value x. So notice started off the first one. We'll do the first one first. It says f of 1/3 x plus 1/3. Notice we're just plugging in place of those, we're plugging these things in. So what we're doing is we're canceling out. I'm sorry, I lost my train of thought for a second. We're getting rid of these fractions divide by 3. So in order to cancel out dividing by 3, you're multiplying everything by 3. And that'll cancel them out. And it leaves you with 1x plus 1 minus 1. And then when you solve 1 minus 1, it leaves you with x. Same thing's true for the other one when you're talking about the inverse of f of x. 1/3 times 3x minus 1. This time we're canceling out, just like the last one we canceled out dividing by 3. Now we're canceling out multiplying by 3x. So we're multiplying by 1/3 plus 1/3, because this is what we said the inverse was. 1/3 of 3x is going to be 1x, and then 1/3 of -1 is minus 1/3. Notice minus 1/3 when you combine those like terms on the next line, -1/3 plus 1/3 cancel out to leave you with equals x. It's not really as hard as it looks. You're just simplifying, you're just using your normal. If you ever get stuck, you're just using your normal. Please excuse my dear, it's no accident that you learned that first thing in Algebra 1, order of operations. Just follow through your normal order of operations. Look at another example of that. It says verify that f of x equals -3x plus 6, and the inverse of f of x equals -1/3 x plus 2. Verify that they are inverse. So in order for both of these to be true, they're both going to come out just like on the last example. Look back at it. You want both of them to come out equal to x at the end. You want them both to say equal to x. We're going to work through this one real quick, because we had so much difficulty at the beginning of the last one. So if we look back at the first one, it says the inverse of f of x. It says f of -1/3 x plus 1/3. We're going to plug those values in. And the reason this one was confusing is because they did this with it. Okay. So when we look at the inverse of it to begin, we want it to be equal to that. In fact, let's go ahead to the next thing. We'll come back to this one. This is, I think that's more confusing than it's worth. We'll come back to that. Because this is what you need to know how to do right here. It says write the original function. Now we're looking at example number 3 is functions, right? F of x equals 1/4 x squared. Okay. So just like on example number 1, for this one, you want to swap x and y's values. Then you just use your order of operations and you undo it in order to get y by itself. It says 1/4 times y squared. You're multiplying by 1/4 is the same thing as dividing by 4. So in order to cancel that out, you multiply each side by 4. So when you multiply this by 4, it cancels that out. You do the same thing to this side. 4 times x gives you 4x. So that'll cancel it out, leave you with 4x equals y squared. And then again, to cancel out y squared, you take the square root of something. Mentioned that earlier. If you take the square root of the right side, you take the square root of the left side. That'll leave you with y equals. Remember, if we have the square root of 8, we can break that down into the square root of 4 times the square root of 2, which will give you 2 times the square root of 2. The same thing's true as if you have the square root of 4x like this. You can break that down into the square root of 4 times the square root of x. And that's why it becomes plus or minus positive or negative 2 times the square root of x. We're not going to worry about all of this. That's more confusing than it's worth too. Okay, here's one you can do. It says find the inverse function of f of x equals x to the 5th power. Remember, if you cancel out x squared by taking the square root of something, how do you think you cancel out x to the 5th power? Okay, the first thing you want to do with this one is you want to call f of x. Anytime you have that, you want to call that y. So y equals x to the 5th power. Then you want to do just like example number 1, change their positions. X equals y to the 5th power. Then you want to cancel out the 5th power. In order to cancel that out, you take the 5th root. I know that looks funny because you've never really been exposed to that, but that you do it the same way as the cubed root and all the rest of the roots. The nth root, you do it just with a square root little radical symbol with the number that goes with it. So when you do that, it's going to cancel this and leave you with y, which is what you're trying to get, but you have to take the 5th root there as well. So y equals the 5th root of x. As goofy as that looks, that's the correct answer. That is the inverse of it. Okay, example number 4 says finding an inverse function. It says consider f of x equals 1/3 times x to the 3rd plus 2. It says determine if the inverse is a function. Remember, if it's a function, it's going to pass the horizontal line test. So begin by graphing the function and notice no horizontal line intersects the graph. So let's look at the first part of the function, this one here. If you plug in numbers, all of us in here are capable of plugging in numbers 0, 1, and 2. If you plug in a number 0 here, 0 to the 3rd power is going to be 0. 0 times 1/3 is still 0, and 0 plus 2 is 2. So when you plug in 0, that's the point you get. When you plug in 1 right here, you're going to get something that's not quite as neat, but 1 to the third power is still 1. 1 times 1/3 is 1/3, and 1/3 plus 2 is 2 and 1/3. So that's right here. And then when you plug in a number 2, 2 to the third power, 2 times 2 times 2 is 8. 8 times 1/3 is going to be 8/3, like this. 8 times 1/3 is 8/3, which when you make that into a mixed number, 3 goes into 8 2 times. So you have 2 and 1/3 plus the 2 that's at the end is 4 and 1/3. So 1, 2, 3, 4 and 1/3 would be about right there. So if you were to graph that, and I know that sounds goofy to do that, but that's just plugging in simple numbers like 0, 1, and 2. If you plugged in -1 and -2, you're going to get something that goes the opposite way. -1 times -1 times -1 is -1, and then 1/3 times that is -1/3 plus 2 is going to be 1 and 2/3. So that point right there. And the opposite's true when you go the other way. It's going to go down the same amount the other way. This one, this distance here is going to be duplicated here, and that point will be right there. But what it wants you to see from that graph is, since all that work was just to get to that picture, since when you cross through it, it's not, it passes what's called the horizontal line test. So it's two different ways to determine if the inverse is actually a function. You learned what the vertical line test was. That's the original function. When you're talking about the inverse of it, you do the horizontal line test. This is the part that makes a little bit more sense right here. It says write the original function. Replace f of x with y. So all you're doing is, in place of this, we're plugging in y. The next step is to just reverse or just switch x and y. So this is just like example 1 and 2. Then undo the operations. Undo plus 2 next by subtracting 2 on both sides. Now, your order of operations says, please excuse my dear, then Aunt Sally. So we undid this first one. We undid plus 2. That's that. Then you want to undo multiplication of 1/3 times y. So times y cubed. So multiply each side by 3, because multiplying by 3 is the inverse of dividing by 1/3. So it just kind of saves you a step to do that. So that's this step. Notice we left y to the third power for the last step, because that goes with exponents and radicals. They go right there. An exponent is not just squaring something, but it's all of the numbers that are raised to a little number up top, the superscript. So then undo this by taking the cubed root of y to the third. When you do that, you have this cubed root of 3x minus 6 is what's the inverse function. So just work through the order of operations backwards. We have a checkpoint problem. It says find the inverse function. So the first thing you want to do when you find an inverse function, you already have x and you already have y. Swap their positions, x and y. So you should have x equals 1/4 y minus 2, and then undo your order of operations. Undo minus 2. You want it to say y equals at the end. That's what you're shooting for. Y equals. Undo minus 2 by adding it to both sides. X plus 2 equals 1/4 times y. 1/4 times y is the same thing as dividing by 4. So undo divide by 4 by multiplying that side by 4. If you multiply that by 4, do this and this by 4 as well. 4 times x is 4x. 4 times 2 is plus 8. That'll cancel out. Y equals 4x plus 8. The same thing for number 2. Change this to y equals x to the third power. Swap the positions of x and y. X equals y to the third power. And then get rid of the third power by taking the cube root. Do it here as well. Y equals the cube root of x. Then the last step, just to put it back in the form it was in function form like that, you simply write the inverse of f of x equals the cube root of x. Instead of writing y equals, since you're talking about the inverse. Do the same thing with number 3. Change f of x to y equals 1/2 x to the 5th power plus 1. Swap positions. This will be the thing you'll forget to do. You'll do this and then you'll try to get x by itself. Swap their positions. X equals 1/2 y to the 5th plus 1. Get rid of plus 1 by subtracting it on both sides. X minus 1 equals 1/2 y to the 5th. 1/2 times y is the same thing as divide by 2. So multiply both sides by 2. This times 2, and everything over here times 2. 2 times x is 2x. 2 times negative 1 is minus 2. This will cancel and leave you at y to the 5th. And get y by itself by taking the 5th root of that. Do the same thing over here. So the 5th root of 2x minus 2 equals the inverse of f of x.